Mechanical training systems suitable for technical colleges and universities. The mechanical training systems introduces the students to the basic components of mechanical drive system, application, installation and maintenance. This system includes a variety of industrial mechanical components that can be set up on a work surface to industrial applications. Installation of motor, Prony brake, pillow block bearing, shaft, flexible jaw coupling, gear drive system, V-belt drive, chain sag, etc. Calculation of allowable backlash, tension of belt, tension of chain. Dimension: width 165x, height 165x, depth 85 cm, power supply AC 1 phase 220 volts 50 Hz. Objective: to check the shaft run out and the shaft end float of the AC motor. Another step that should be performed as part of the motor mounting process is to check the motor shaft for run out and end float. Run out can be checked by placing a dial indicator on the shaft and rotating the shaft. Mount and level AC motor. Place the level on the top of the motor shaft and observe the position of the bubble. Make sure the level sits on a smooth surface of the shaft. Place a feeler gauge under one end of the level to make the horizontal bubble centered. Use the shim thickness calculated in the motor feet, either the front 2 feet or the back 2 feet, which will cause the level bubble to be centered when install coupling. When the level is placed on the shaft, the total variation in the reading is called the total indicator reading, TIR. The run out is 1/2 of the TIR. If the run out exceeds 0.05 mm, the motor should not be used. High run out means either the motor shaft is bent or the bearings are worn. Run out can actually be checked at any time during the installation process. Also, the motor should be checked for end float or end play, as it is also known. End float is the amount of free movement the shaft can make along its axis. This can be checked by placing an indicator on the end of the shaft and moving the shaft in and out. The end float should be checked against the manufacturer's specifications. A typical end float is 0.03 mm, but this can vary. If end float is excessive, the motor should not be used because it can cause misalignment. Operate the motor and use a tachometer to measure the rotation speed. Basic knowledge: the photo tachometer uses a beam of light pointed at a piece of reflective tape that has been placed on the motor's shaft. The photo tachometer counts the number of times the tape passes through the light. Once the speed has been determined, it is shown on the display. This method has an advantage over the handheld mechanical tachometer because you do not come in direct contact with the motor shaft. However, some models have attachments which enable you to take direct readings if necessary. To demonstrate the torque output changes as the power is transmitted through various types of mechanical drives. Fill the brake drum with 10 milliliters water. The Prony brake is one device that is used to load a motor. This device also has the ability to tell you how much load is applied to the motor. The Prony brake drum is coupled to the motor shaft and rests inside a friction belt. As the belt is tightened against the brake drum using the wing nut, the load on the motor is increased. This applies a force to the arm. The force is measured by a spring scale that is placed at a specific distance from the center of the motor shaft. This is the radius distance. You can then use the force reading from the scale, and the radius distance can then be used to calculate the torque. Install and adjust pillow block objective, the shaft inserted between the two pillow blocks. Basic knowledge: a pillow block consists of a housing with two mounting feet which are oriented so that the shaft can be mounted to a horizontal or angled surface. A pillow block can be designed as either a single assembly or a split assembly. Perform the following steps to mount the shaft within two bearings. The shaft must be straight and round. It must also be free of burrs, nicks, oil, lubricants in order to properly lock into the bearing. Place the level on the top of the motor shaft and observe the position of the bubble. Make sure the level sits on a smooth surface of the shaft. Place a feeler gauge under one end of the level to make the horizontal bubble centered. If the bubble is shifted to the right, shim the left end of the level. If it is shifted to the left, shim the right end. The effective level length is the distance between the point where the level is contacting the shaft and where the level is contact the feeler gauge. Use the shim thickness calculated in the motor. Feet. Either the front 2 feet or the back 2 feet, which will cause the level bubble to be centered when the level is placed on the shaft. Mount and level AC motor. Place the level on the top of the motor shaft and observe the position of the bubble. Make sure the level sits on a smooth surface of the shaft. Place a feeler gauge under one end of the level to make the horizontal bubble centered. Use the shim thickness calculated in the motor feet, either the front 2 feet or the back 2 feet, which will cause the level bubble to be centered when install coupling. When the level is placed on the shaft, to install couplings to connect a motor to the shaft. Couplings are used to connect two shafts for torque transmission in varied applications. Coupling may be rigid or they may provide flexibility and compensate for misalignment. They may also reduce shock loading and vibration. There are two main types of couplings: rigid couplings and flexible couplings. Rigid couplings are used for shafts having no misalignment, while flexible couplings can absorb some amount of misalignment in the shafts to be connected. Install and align gear drive system. Perform the mount and level the gear motor. Check the level of the motor shaft. Shim the motor feet as needed for motor shaft end float. End float should be less than equals 0.03 mm. The motor shaft for run out. Run out equals 0.04 mm. Shim the motor, then use the square to establish the right angle and tighten the screws. Perform the following steps to mount shaft B2, shaft panel 2, and pillow block bearings B4, shaft panel 2. Place the double stand S3, stand panel, on the work surface. Use the square to establish the right angle, then fasten the screws. Place the pillow block bearing B4 on the stand. Slide the shaft, B2, through the two pillow block bearings. Tighten the screws on each bearing to lock the bearing. Tighten the pillow block bearing screws to the stand. Check the driven shaft for run out. Run out equals 0.04 mm. Note the shaft run out should be less than 0.05 mm. Level the driven shaft. Place the shim between the stand and the pillow block bearing. Repeat a similar manner to mount the shaft B1, shaft panel 2, and pillow block bearings B3, shaft panel 2, on the double stand S5, stand panel. Install the Prony brake and the brake drum on the shaft B1. Perform the following steps to mount gears D6, 24 teeth, and D8, 48 teeth, from gear drive panel 1. Insert the key into the keyseat of shaft B1. Slide the gear D8 onto the shaft until the face of the gear is flush with the end of the shaft, B1. Slide the gear D6 onto the shaft until the face of the gear is flush with the end of the shaft, B2. Tighten the screws. To install flexible jaw couplings to connect a motor to the shaft. The flexible jaw coupling is a type of flexible coupling which uses a rubber called a spider to connect the two hubs. Each hub has jaws that mesh with the spider. When the driver coupling half rotates, its jaws press on the spider, which in turn press on the jaws of the driven coupling half, causing it to turn. This type of coupling belongs to a family of couplings called elastomeric couplings, which refers to couplings that use a rubber to separate the two coupling halves. Specifically, it is a type of coupling called an elastomer in compression. Check the gear alignment by placing the ruler against the faces of the two gears. The driver gear must be aligned with the driven gear. If not, move the two gear to a position where the gear touching the ruler. Tighten the screws of the gears. Install and align chain drive system. Place the motor adjustable. Use the square to establish the right angle, then fasten the motor. Check the shaft for run out. Motor shaft end float. It should be less than 0.05 millimeters. Check the level of the motor shaft. Shim the motor feed as needed. Perform the shaft B1, shaft panel 2, and pillow block bearings B3, shaft panel 2, on the double stand S5, stand panel. Place the stand on the work surface, fasten the double stand with screws. Place the pillow block bearings B3 on the stand. Slide the shaft B1 through the two pillow block bearings. Tighten the set screws on each bearing to lock the bearing to the shaft. Turn the shaft by hand to make sure it turns freely. If not, loosen the screws and adjust the positions of the bearings. Check the driven shaft for run out. The run out should be less than 0.05 millimeters. Level the driven shaft. Shim the stand as needed. Place the shims between the pillow block bearings and the stand. Install the Prony brake and brake drum S6 on the shaft and work surface in the location. Perform the sprocket F1, 15 teeth, from chain drive panel 1 to the motor shaft. These steps are the same steps you use to install the drive system. Insert the key into the key seat of the motor shaft. Slide the sprocket F1 onto the shaft. Repeat a similar manner to mount the 30-tooth driven sprocket F2 from chain drive panel 1 onto the driven shaft. Check the sprocket alignment by placing the long straight edge flush against the driven sprocket face. Then check the position of the face of the driver sprocket. Perform mount the chain and belt panel. If more clearance is needed, loosen the fasteners on the motor mount and move the motor mount toward the driven shaft. Position it close enough to be able to put on the chain. Place the chain over the sprockets. Adjustment the motor until the chain does not touch the work surface. Tighten the lock nuts against the motor. To assemble and align a chain drive which will be used to drive. The roller chain is the most common type of chain used in industrial chain drive systems. Single-strand chain is the type of chain which you are most familiar. The single chain is made up of a single row of rollers with plates on each side. Single-strand roller chain is used for most general-purpose applications of low to medium power transmissions. This type of chain is also found on bicycles. Multiple strand chain, for applications that transmit a great deal of power, can be used. Multiple strand chains are made up of two or more single strand chains. The chains used in multiple strand chain drives are the same as those used in single strand drives. They are merely joined to create multiple rows. Multiple strand chain is used in applications with much heavier loads and higher speeds than a single strand chain can handle. Double pitch chain has the same construction as standard roller chain except that the length of its links are twice that of the single pitch chain. Double pitch chain is normally used when trying to save money and the application has low loads and speeds. They are also used in conveyor drives. Offset chain is made up of two different links that mate with each other. Offset chain, sometimes called cast chain, is made up of a single kind of link. Offset chain can come with or without rollers. Because of its offset design, this type of chain doesn't require a connecting link, which is usually weaker than the rest of the chain. For this reason, offset chain is normally made out of high-strength steel to be used in heavy load, low-speed applications. Perform the place the motor adjustable. Install the Prony brake and brake drum S6. Perform the following steps to mount the V-belt, chain and belt panel. Place the belt over the pulleys. Adjust the motor base until the belt straightens out and adjust the lower jam nut to support it in this position. The belt should be straight, but it should not have any tension in it yet. Install the pillow block bearings B3, shaft panel 2, and the shaft B1, shaft panel 2, on the double stand S5, stand panel. Perform to mount the pulley E4 and E3, belt drive panel 1. Insert the key into the keyseat of the driven shaft. Slide the pulley, E4, onto the motor shaft. Tighten the screws to the pulley. Repeat a similar manner to mount the pulley E3, belt drive panel 1, onto the driven shaft. Perform the adjustable motor. Adjustable mounting to the work surface. Place the motor on top of the adjustable mounting bases. Check the shaft for run-out. The run-out should be less than 0.05 mm. The driver pulley must be adjusted so that it is aligned with the driven pulley. This is because in real-world applications, it is usually easier to adjust the motor's position than it is to reposition the drive component. If no part of the driver sheave is touching the straight edge, the sheave grooves are also considered to be misaligned and the shafts may also not be parallel. Reposition the motor until the driver pulley is aligned with the driven pulley. The central shaft systems started to be replaced by electric motors which were placed at individual machines. This made power transmission more efficient, flexible, and lower in first cost. It also permitted higher speeds, which could enable even higher efficiencies and higher machine productivity. In 1917, the Gates brothers, Gates Rubber Company, invented the V-belt to support this application. The V-belt is a wedge-shaped belt, which is made from a combination of rubber and textile material. The V-belt is designed to grip the walls of a grooved pulley by wedging itself against the sides of a pulley groove as the belt is tightened. The V-belt drive is commonly used in applications such as fan drives, air compressors, and car engines. Perform the place the motor adjustable. More accurate method of tension measurement is the force deflection method, using a tension tester or belt tension checker. The tension tester is a handheld device which measures belt tension by measuring the force needed to deflect the belt a certain amount to actually perform the test. The tester should be placed in the middle of the belt span and forced down until the belt is deflected by the proper amount. The force indicated by the tension tester is then read. This force should be compared to a recommended force deflection range. Compare your force reading with the force range you calculated. If your reading is within the range calculated, you have tensioned the belt to the correct level. If the force is above or below this range, you need to readjust the tension on the belt and check the tension again. Perform the mount the adjustable motor base. Use the square to establish the right angle, then fasten the adjustable mounting base to the work surface. Perform the following to level the motor on the adjustable mounting base. Place the motor on top of the adjustable mounting bases. Tighten the motor to the adjustable mounting base. Run the top jam nut to the bottom of the adjustment screws and turn the lower jam nut to lower the adjustable portion of the motor mount.